commonly used notations in sets and other areas for your exams. Okay, so these are notifications or notations that you are supposed to know. Let's start with the most common ones. One is the set of all natural numbers given by n. Set of all natural numbers given by n is basically all numbers x such that x is equal to 1, 2, 3, dot, dot, dot. You can also write it as in the roster format 1, 2, 3. Basically, whole numbers greater than 0. That gives me the next definition, whole number, W. W is 0, 1, 2, dot, dot, dot. N is the set of all natural numbers. Natural numbers, set of all whole numbers. Basically, then I can say that the set of all natural number is a subset of the set of all whole numbers. Then we have the set of all integers. Set of all integers is basically dot, 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 -2, -1, 0, 1, 2, 3, dot, dot, dot. Set of all integers. Okay. Set of all integers is this. Then you have Z plus, set of all positive integers. Set of all positive integers, which is the set of all natural numbers. Z minus, set of all negative integers. Okay. Then you have Q, set of all rational numbers. Set of all rational numbers is basically P by Q, of the form P by Q, where P and Q are co-primes and PQ are belonging to integers. What does co-prime mean? Co-prime basically means that they are prime to each other, right? So P and Q don't cancel out. It's not a situation like this that 3 by 6. 3 by 6 are not co-prime to each other. The rational number is actually 1 by 2. So you have to break down a P by Q into the lowest format such that the numerator and the denominator don't cancel any further. Okay. That is the set of all rational numbers. Okay. Set of all irrational numbers is given by T normally. Okay. How is it? It's basically the set of all real numbers minus the set of all rational numbers, where real number is basically a set all x such that x is lying between -infinity to +infinity. Any x that is lying between -infinity to +infinity is a real number. Another set is complex number. Complex number is basically the set of all real numbers complement. Okay, complex number is of the format root over of a negative number. Okay. 0 will not be a part of the positive or the negative integer. 0 is a part of only z. 0 is a part of only whole number. Okay, unless otherwise specified. If they say the set of all positive integer, it starts with 1. The set of all negative integer, it ends with -1. Okay. C is the set of all complex numbers. Okay. Since I have T is the set of all irrational numbers. Irrational. Set of all irrational number. An example of irrational number, √2, √3. Okay. Irrational numbers are numbers that have non-terminating and non-repeating decimal. Okay. Non-terminating and non-repeating decimal. Like for example, pi, e. These are all examples of irrational numbers. √2, √3, √5, √6, √7, √8, √10. These are all irrational numbers. Their decimal does not follow any pattern and it is not terminating, it's not ending, it's going on. Okay. So whenever I have a terminating decimal or repeating decimal, those will be rational numbers, that is Q. Everything else will be irrational. And R is the set of all real numbers. Okay. C is the set of all complex numbers. Complex numbers are also called imaginary numbers. All right. Set of all complex numbers, set of all imaginary numbers. These are a few notations that each of you should know. This is asked multiple times in these entrance examinations. And because you can work so much with the complement, with minus, that's why I wanted to show you the operations before I went into the common notations. Okay. Right. This is what we have here. Next. Next, let's also talk about a few more operations and a few more definitions that are important. Yes, the number 2, 3, these are all rational numbers, Vedika. So the number 2 can be written as 2 by 1. So 2 and 1 are co-primes. So this is a rational number. So basically the set of all natural number, set of all integers, okay, these are all subsets of rational numbers. In rational number also you will come across notations like this. This basically means set of all positive rational numbers. Okay, so imagination is the endpoint. There are just so many things that you can do with these sets. I basically wanted each of you to get comfortable with the notation N, Z, Q, T, C, R. So I wanted all of you to get comfortable with these different kinds of sets which are asked in all aspects in mathematics, economics, all areas. 2 by 0 is undefined, Shivank. 2 by 0 is undefined. P and Q should be co-prime to each other and Q should not be equal to 0. Yeah, Q should not be equal to 0. It becomes undefined. Okay. That is what it is. Okay. So I hope each of you are now a little more comfortable with the different definitions that I have given for the different sets of numbers. Okay. After having understood this, it's a good opportunity to go into the different operations and different definitions related to operations. Definitions related to operations on set. So we have seen intersection, union, complement, difference. We have seen all that. So now is a good time to go into definitions related to these operations. First definition is that of a disjoint set. Now, what is a disjoint set? A disjoint set is a set whose intersection is a null set. That is, two sets that do not have any common element. Two sets that don't have any common element. They are also called mutually exclusive. Okay. Sets that are disjoint are also called mutually exclusive. Another important definition, intersecting sets. Intersecting sets are the opposite of disjoint sets. That is, A and B have something in common. So sets that have something in common are called intersecting sets. Okay. Okay. So something is common in between A and B. Okay. Some important laws. Okay. Sets are idempotent. What is idempotent? Every set is a subset of itself. Identity, commutative, these are all aspects that are included into idempotent. Okay, identity and commutative. Then we have associative. This can be easily written as A union B union C. Similarly, A intersection B intersection C can be written as okay. Then comes the important distributive law. Distributive law is when I have intersection and union. So this can be written as A intersection B union A intersection C. Distributing this into the elements that are inside. And vice versa. A union B intersection C can be written as A union B intersection A union C. Okay. two laws that we have already seen when we were working with operations. That is the De Morgan's law we saw in the previous session. De Morgan's law, we have already seen that A union B complement is A complement intersection B complement. Similarly, A intersection B complement will be A complement union B complement. Okay. These will all be provided as a note. So I'm only doing it very quickly just to put it there in your head that these are the different definitions that we need to work with when we talk about sets. Okay. Now let's talk about some important results. That need to be known. If A is a subset of B, if A is a subset of B, then B complement will be a subset of A complement. Something that we have already seen when we were seeing the operation of difference. A intersection B complement is how we will refer to A minus B. Okay. A minus B intersection B. If I remove B out of A, so this will have no intersection with B, so this will always be a null set. A minus B union B minus A. A minus B union B minus A is basically A union B minus A intersection B. Okay. If A minus B is equal to A, then that obviously means that A and B do not have anything in common. If A minus B is equal to A, that means that A intersection B complement is A itself, right? So there is nothing common between A and B, or A and B are disjoint sets or mutually exclusive sets. Can you tell me when will A union B be equal to A intersection B? When will this happen? Can you put it in the chat box, please? Most of you are absolutely bang on. If A union B is equal to A intersection B, that means A and B are equal sets. A and B are the same. तभी तो union and intersection is the same. Number 7. If I know that A is a subset of B, then for any other set S, S minus B will be a subset of S minus A. They are not equivalent sets, they are equal sets. Equivalent means that the number of elements are the same. Number of elements can be same for different sets also. Anyway, 7th one is this one. If A is a subset of B, then for any other set S, S minus B will be a subset of S minus A. Okay. A union A intersection B is the set A itself. A intersection A union B is the set A itself. Is the set A itself. Yeah, seventh one. Seventh one will be very easily seen once we understand Venn diagram. Okay, it can be easily seen with the Venn diagram. It's like this, that if A is a subset of B, if A is a subset of B, then for any other set S, S minus B will be this entire part gone. S minus B will be this entire part gone and only the lower part of S. And S minus A will be only this part gone from S. So S minus B will be a subset of S minus A because more elements are being removed here than here. Okay. So it will be better understood when we take a look at what is a Venn diagram and the definitions where I have not yet landed. Okay. Okay. So these are a few definitions that I wanted to share. Okay. Yeah. These are the different definitions.